have not graded the exam yet. There's one student who's waiting to take the exam, and as soon as the student takes the exam, I'll grade it and hopefully bring it to you on Monday. Right? Okay.
So the assignments,
Right.
Is it Monday to get it in there?
The assignment that you're working on currently?
Yeah.
Yeah, that's fine to submit it Monday.
Just maybe not all of them. No.
Oh, well, I wouldn't say that. I mean, you'll lose some credit, but even if you're behind, try to submit the assignments. Okay. All right, so let's continue on. So we have covered most of the basic material as far as C# is concerned. So now we'll take a look at slightly more advanced material. Okay. So one of the next topics that I'll describe is called generics. Okay. So the idea behind generics is to make, especially sometimes we write code which operates on a particular data type. So using generics, we can easily make it such that the same code will operate on different data types. So for example, hey, let's say you wrote some a function to swap two integers. So your code to swap two integers will look something like this. Okay. int temp equal to A equal to B equal to temp. Right? Okay, so suppose you wrote this function in some class, right? So now your test code, the code that will try to call it, might look so in some kind of a button handler, you will do something like this. Okay, int, let's say x equal to 5, int y equal to 7, right? And then you will call swap of x comma y. Okay, and then you'll try to print out the values. So you will, whatever message box that show, let's say a equal to, x equal to plus x dot toString plus y equal to plus y dot toString. Okay, so if we run this program and click on this button, right, and pretend this swap method is also written inside the same form class, okay, what will be our output? What's your guess? Will it be 5 and 7, or will it be 7 and 5? Okay, if you're not sure, let me describe one fundamental concept. So most of the time in C-style languages, not always, so for example, C++, Java, C#, I refer to these as C-style languages. Okay, whenever we call a method, so calling mechanism is what we call by value. Okay, so what exactly we mean by call by value? Okay, in call by value, what happens is a new memory is created for the parameters. So new memory is created for the parameters. Okay, and then we copy the data from the corresponding parameters into the new memory. So for example, to show you this part, if we click on the button, what will happen if this is the memory of the computer? Okay, there's X, there's Y, right? So the computer will allocate memory for X, memory for Y, will store 5 over there, 7 over there, right? Now it calls the function, right? So take a look over here, 7 corresponds to A. y corresponds to b. So there's a one-to-one correspondence. So this is what I meant, because the default mechanism, so I should say the default. We can change it, but if we don't do anything special, it will do call by value, okay? X corresponds to A, so as I mentioned, new memory is created for the parameters. What are the parameters? A and B in this case. So the computer will allocate new memory for A, new memory for B, because X corresponds to A, we'll copy this over here. Y corresponds to B, so we'll copy the data into B. And then it will start to execute the method, right? So int temp equal to A, so we'll create memory for temp. Temp equal to A, so this will become 5. A equal to B, so this will change to 7. B equal to temp, so this will change to 5, right? Now, as soon as the method is done, the function is done, we lose memory for whatever parameters that we had allocated. Okay, so as soon as this is done, the local variable was temp, A and B were the parameters, all of this is destroyed. Okay, so even though we did exchange A and B to 7 and 5, but as soon as the method ended, we lost this memory. So now if we go to the calling code, what will we find X and Y to be? Still 5 and 7, right? So this is what it will produce, but the purpose of this method was to really exchange the data, right? So in C#, just like in C++, we can use the ampersand to indicate call by reference. In C#, there's a keyword called ref. So if you add this ref keyword, that means we are trying to call these parameters by reference. So what's the difference between call by value, call by reference? In call by reference, okay, we use the same memory. For the parameters. Okay, so in call by reference, okay, now the rule is not only you have to put the ref keyword over here, in the call also you have to put the ref keyword, so that there's no ambiguity. You are indicating that both parameters should be passed by reference. Okay. So how will the memory work out in this case? Again, computer will start out by allocating memory for X, memory for Y, right? Putting 5 over there, 7 over there. Now, again, X corresponds to A, Y corresponds to B, so there's a positional association. Okay. However, now there's a ref keyword. And as I mentioned in call by reference, we use this, we don't create new memory for the parameters. So what the computer will do is temporarily rename X to be A, temporarily rename Y to be B. Then it will start to execute the function in temp equal to A, so it will allocate memory for temp. Whatever is in A, it will copy over here, so this will become 5. A equal to B, so we'll change this to 7. B equal to temp, so it will change it to 5, right? And now, as soon as the function ends, what do we lose? We only lose this temporary association, okay? We can't lose the memory because that was created by the calling code. So we get rid of A, we get rid of B, right? So now if we go and try to print it over here, what will we find?
7 and 5.
7 and 5 in the memory, right? So the moral of the story is, if you want the function to change the parameters, what do you have to do? Call by reference. Otherwise, if you don't want the function to change your data, then leave the default, which is called by value. Okay. So to give you another example, okay, suppose I asked you to write this compute function, and it looks like this: int A, int B, ref int c and something void, right? And suppose you are doing a equal to a plus 2, b equal to b plus 3, c equal to a plus b, right? And suppose you call this function like this. You call the compute by x equal to 3, y equal to 5, z equal to, let's say, 7. So you did x, y, ref c. Okay, see, you don't have to have all the parameters by reference. You can pick which one you want to call by reference, right? So in this case, if I gave you this type of problem on the test, what will be the answer produced if we try to print x, y, z over here?
3, 5.
Okay, see, x and y, even if it tries to change them, will lose that memory, so that change will never be reflected, right? So you don't even have to worry about what it's doing. It will exactly stay the original value, so 3 and 5, right? So now z is by reference, so that will change. So that you do have to figure out. So this was 3 to begin with, so this becomes 5, right?
5 and
8, and then this will become 13. So z will be 13, right? So anyway, so now that you understand how do we pass something by reference and something by value in C#, okay, so once again, ref keyword is needed to call by reference, both in the method as well as in the calling code, okay? Now next question, or next concept, okay? So suppose you had written this function in, let's say, you created some class, utils or whatever, and you wrote this function, right, inside it, okay? Now, what is this doing? This is exchanging two integers, right? What if somebody, as you were developing your application, not only you needed to exchange integers, you also needed to exchange doubles, okay? So if you also needed to exchange doubles, what will you do? One possibility is you'll just copy and paste this code, right? So you'll copy from here to here, paste it again. So let me pretend we copied and pasted. And you will change this to what? Double. Let's say a ref